Oh shit, we're live. Alright, hello. Hey everyone. This looks interesting. Valve new handbook for new employees. Let's see what we get. We set out to make great games. Preface. Huh. Alright, how to use this book. This book isn't about fringe benefits or how to set up your workstation or where to find source code. Valve works in ways that might seem counterintuitive at first. This handbook is about the choices you're going to be making. There is a official Valve intranet. Look for stuff like there's how to build a Steam depot or whether eyeglasses are covered by. Okay. Interesting. Welcome to Valve, your first day. Unique way of doing things. Valve is self funded. We've never brought in outside financing. Very nice. Okay, I like that. I like that. Valve owns its own intellectual property. Okay, cool. We're just Hey Justin, what's up? Valve is more than a game company. Started existence as a pretty traditional game company. Hmm. All right, let's see. Okay, so they basically own their own company, which is great. I always like seeing that, especially when you're not beholden to outside investors. I actually like that a lot. Welcome to Flatland. Hierarchy is great for maintaining predictability and repeatability. Um, Telling them it doesn't include with the total obliterates 99% of their value. We want innovators. Okay, Valve is flat. Sweet. We do have a founder and president, but even he isn't your manager. The company is yours to steer towards opportunities and away from risks. Okay, so a very flat organizational structure. All right. Interesting. The every company will tell you the customer is the boss, but here that statement has weight. What do you mean? There's no red tape stopping you from figuring out what our customers want and giving it to them. Okay. Literally okay, you're basically hiring people who not only they're talented or collaborative, but if they're capable of literally running this company because they will be. I thought that's very interesting actually to basically literally treat them as owners. Your first month, you know, you pretty sure you know what that one guy's name is. Pick your own projects. Everything's self-directed. At Valve, that percentage is 100%. You'll decide what to work on after asking the right questions. Vote with their desk wheels or feet. If you're working here, that means you're good at your job. Okay. You were not hired to fill a specific job description. You were hired to constantly be looking around for the most viable work you could be doing. I like this attitude, actually. I think it's very reminiscent of like a staff engineer. What's the most valuable thing I can be working on? Which project has the highest direct impact? Is Valve not doing something that I should be doing? What is interesting? What's rewarding? How do I find out projects that are underway? Okay, like current projects. Lots of people at Valve want to be, and you know what you're good at. So get a lay of the land. Got an idea of how we can internal broadcast project and company status. Okay. Move your desk there. All right. Short-term versus long-term goals. And we're faced with problems and threats, clear costs. This sounds like a good thing, it often is, but has some downsides worth keeping in mind. If we're not careful, these told me to work on X and they've been here a long time. Well, the correct response to this is to keep thinking about whether or not your colleagues are right. Broaden the conversation. Hold on to goals if you're convinced they're correct. Check your assumptions. Pull more people in. Listen, don't believe that anyone holds authority over the decision. They don't. But they probably have valuable experience to draw from or information you don't have or insight. When you consider the outcome, don't believe that anyone but you is a stakeholder. You're it. You're the stakeholder, and Valve customers are who deserve it. Okay, here's something interesting. Is that no matter what happens, the human nature is always a thing, right? It's you're always going to defer to authority. Like if tomorrow, let's say I don't know Tifu or I don't know Ninja or whatever told me how to do my stream, I'm not gonna tell him to fuck off. I'm probably just gonna do exactly what he says, you know, because these people are like they're in the streaming business. They know exactly they have the results to show for it, and so an appeal to authority basically almost always makes people's brain melt. It's I think there's a story of whenever Boeing did like some what's called evacuation tests, they improperly did the test. So what they're supposed to do was, you know, in case of like a storm or they would simulate like a storm or fire or something, and then they would basically have everyone try and practice a drill of evacuating the aircraft. But the problem is that they didn't set up the I think the safety pillows. and it was always, and in the dark, you're kind of hoping that someone actually did. So when it was time to do the drill, right? And they sounded the alarm, everyone was jumping out of the plane, except, these planes are like 30 feet up in the air in the hangar. And so people were breaking their backs and jumping because, there's an alarm and someone told them, hey, we have a drill, go jump. And they jumped. Even though and so they figured they tried to work out the kinks and then they tried again and people were still jumping. You also have these studies where people who are like, two people in an aircraft, like a fighter jet, right? You have a pilot and a co-pilot. And then you have someone in the back telling the person in front what to do, right? It's like, oh, watch out for this, watch out for that. You need to dive left, you need to dive right? And so the pilot needs to trust the co-pilot completely. So when the co-pilot, he's seen as like a form of information and authority. So when the co-pilot says dive into the ground, or should I say, turn left, even though turning left would obviously kill you if you flew directly into the ground, well, people would still do it. So I don't know. This thing about authority, I think that this is like kind of wrong to just say, hey, be rational about it. Human beings are not that rational. I'm sorry. What are things that I'm not getting done? This natural kind of environment does not feel like you're failing because every single task. No expect you to devote time to every opportunity that comes your way. Pick what you do most. Yep, this is super important. I think anyone who is interested in becoming like an effective engineer and work on ambiguous problems really need this. We constantly test our own decisions, whether we move into unknown territory to find. We find test your own assumptions. Okay, yes. Testing takes a pause. Okay. Accepting truisms, Alright, whatever. Recruiting can also be difficult. Can I be included the next time Valve decides X? Yeah, start working on it. Okay. Cabals are really just multidisciplinary project teams. We've self-organized into large temporary groups since early days of Valve. They exist to get a product or large feature shipped. Okay. Someone emerges as technical lead, yes. Structure, yes. People essentially will organize themselves in structures naturally at hierarchy or not. I think what they're trying to go for is like the naturally grown organization. I understand that. Okay, so they're really saying you pick your own hours, but you really need to have balance. I don't know. If you feel that you find yourself working long hours or generally just feel like balance is out of whack, be sure to raise the... Okay, this is These are... Raise the issue with whomever you would feel help. Dina loves to force people to take vacations. The office, fresh bowl of fruit, relax. I don't know. For me, I've always been the kind of person where it's like, if I need to do something, I'm going to spend, I don't know, I don't care if it takes 10, 12 hours a day to do it. And so I've kind of rejected, I kind of reject the work-life balance narrative. It's like, just work until you really need the break. That's kind of been the way I kind of go at things. And I think that, I would say it's kind of difficult to really, for me to like kind of connect with people who can't really see themselves doing that. It's like the people who oversubscribe to work-life balance. And I think that's been a very difficult pain point and sore point for me when it comes to trying to get along with people. It's like if people say something like, oh, I want to do XYZ. I'm like, great, what are you doing to get there? And I hear them like, kind of just bullshit around. I'm just like, no, screw this, fuck this guy, So, what if I screw up? It doesn't make sense for us to operate that way. Providing freedom to fail, important trait of the company. Screwing up is a great way to find out your assumptions are wrong. As long as you update your model and look forward. Yep, there's still bad ways to fail. Repeating the same mistake over and over is one. Not listening to customers. Never ignoring the evidence. Particularly when you say you're wrong. Yeah. Talk to someone in the meeting, elevator, kitchen, or bathroom. The bathroom. This little square here, nice. But what if we all screw up? How's that not chaos? Yep. Our collective ability to meet challenges, take advantage of opportunities, and respond to threats. Namely, yeah, we're all stewards of our long-term relationships with our customers. They watch us very publicly and make mistakes. Okay. Sure. Pierce review. Stack ranking is done primarily as a source of adjusting compensation. Sure. There's a formation framework for how we give this framework to people. Our profitability per employee is higher than that of Google or Amazon or Microsoft. Wow. Yeah, that's interesting. Valve does not win if you're paid less than the value you create. And people who work here ultimately don't win if they get paid more than the value they create. Yeah, that's true. Honestly, I like this. I think they're really trying to make this a meritocracy. Which I think is good in theory, but I'm not quite certain how it would work in practice. We believe peers are the best judges of our values as individuals. I think that this is interesting because you need to have basically an organization in society that has a lot of earned trust in order to make this work. So I feel like Valve cannot go mass hiring in a corporate structure. I don't know. It's kind of interesting here, but we're out of time. Let me bring on my client and let's see. Let's see what's up. Oh, god damn it.
Oh.
Hey, what's up?
Hey, Albert.
Hey, how you doing?
Good, man. How
Yeah.
about yourself?
How's the week off?
It's been good. Just resting. Yeah, just trying to rest and do some stuff around the house. So yeah, it's been good.
Gotcha. Yeah, you feel like relaxed and ready to get back at it?
Yeah, somewhat. Yeah, feeling much better than I was a week or two ago. So.
Yeah. Yeah. So if that's the case, then yeah, we're just gonna mostly be trying to We're mostly gonna hammer, your destruction algorithms thing. So and I'm gonna invite the other guy in. So
Okay.
both of you are gonna be interviewing each other. So yeah, let me bring him in, and then I'll talk about what's going on.
Okay. Perfect.
Hey, hello.
Hello?
Hey, what's up?
Okay, good. Get my mic.
Yeah, your mic is kind of low, dude.
Oh, damn it. Okay. Give me a minute.
Yeah, it's all good.
Okay. Does this sound a bit better?
Yeah, I guess a little bit better. Can you hear him?
It's still a little low. Yeah.
Yeah, you gotta adjust your mic, bro.
Okay. I'm at the max settings. Hello?
Okay, better. Yeah, cool.
Okay.
All right, cool. So yeah, welcome to the stream. How have things been with you since your Google interview? I know Google's been taking its sweet time for getting back to you.
Yeah, they are taking their sweet time getting back to me. I've been emailing my recruiter almost every week on any updates. She still says no updates so far. Other than that, I've just been doing a couple of problems. When I had the time to. Other than that, it's just schoolwork and applying to these new jobs, and yeah, doing the always if they give it to me, and redoing my resume every so often.
Okay. Yeah, your mic's still a little bit low, by the way. You might want to crank it up.
I'm just gonna talk right in front of the mic.
Okay, that's probably better. All right.
Yeah.
Cool. All right. Yeah. So you're always still kind of drilling the data structure and algorithm stuff. Yeah. So let me describe what's going to go on. So basically, I find that both you kind of have the same habits when it comes to data structures and algorithms, where you both kind of meander, you both ramble, and you're both not really you don't have the best ability to simplify your language. So I kind of thought it'd be interesting for me to basically hold up a mirror in front of you guys, and so you can see your mistakes in the other person, and then maybe you might be able to recognize that in yourself. So one of you is gonna go first and interview the other. I'm gonna maintain timer, moderate, and whatever. And I'll make my notes, but I would encourage you guys take notes on the other guy as well. In the same style as, hey, I think you made this is what you did at this time. here's how I think this is what I think is a mistake or not. And so after each question, we'll allocate like basically 30 to 40 minutes for each person. Do 20 minutes review, look at compare notes, and then we'll switch off. Sound good?
Cool.
Yeah, sounds
All right.
good.
So who wants to go first? Who wants to be the first victim here?
Hold on. So, where are we gonna do the problem? I guess. Am I
Yeah.
gonna go on like?
So I'm linking you to a Google Doc. So everyone will have access to this one.
Okay.
Okay.
Yeah. So both of you should have access to it. And between you, J or C, pick who wants to go first. I'll let you decide.
Do you want to go first, or should I go first? Maybe interview. You want me to interview first? I guess.
Yeah, I'll go first, man. No problem.
Okay. So C is gonna be the interviewee. J is gonna be the interviewer. Jay, you're gonna have to talk closer to your mic, by the way.
Hello. Yes.
Okay. Cool. I'll take notes. I'll take this timer, and I'll tell you when to begin.
All right. So let me copy my question.
Yeah, both of you should have. I emailed you guys earlier and told you, hey, prepare a question ahead of time.
Yeah.
So let's see. Let me get the timer out. Okay, there we go. All right, and then here we go. Cool.
All right. So, hold up. Okay, I can type. Why isn't my copy paste working? Okay, there you go. So yeah, this is the problem. You're given a stream of elements, and you have to find the kth largest one.
Okay, so designing out the kth largest element. Yeah, so one thing that's not clear is this is a stream, right? That's what it sounds like here. So what is going to determine when to stop consuming elements? That's my question. Is that is this something that I'm just gonna call, for example, like kth largest, right?
Yeah.
And as I'm consuming elements or as I'm streaming the elements, I would insert them into a list or somewhere, insert into a list, right? And let's say the list is 1, 2, 3, 4, 5, right? The kth largest element, let's say 5, right? Just for the sake of this example, it would be this answer, right?
For what's k again?
K equals 5 here.
Okay, yeah. So k equals 5, then yeah, that'll be fifth largest element. Yeah.
Okay, and if I insert more elements, like these aren't necessarily order. The fifth largest element, it would be, let me see, 1, 2, 3, 4, 5, 2, 3, 4, 5. Okay, so is okay, one thing I'm not understanding here. I'm going to maintain some sort of data structure, right? Where I'm inserting all these elements, and you want me to retrieve the kth largest element.
So you can assume you're just given this stream. Like you can treat it essentially like a list of unknown length, sort of thing. And then you just try and find the kth largest in that list of unknown length.
Okay, so the kth largest. Okay, so I'm thinking here, by the kth largest, that means that the array has to be sorted somehow. So if I say, okay, so, okay, one thing I need to get clear here, by kth, what do you mean here? So if I say let's say k equals 1, right? K equals 1. K equals 1. The kth largest element, that would be one. That would be the first element, right? No.
Yeah, well, k. No, first largest should be like 20, I think, if we're including these elements.
Okay. Looking at, okay. I see now. Okay, so the k equals 1, that would be 20. It's okay. Okay, so right off the bat, I'm thinking with this stream, I can insert it into a heap. And then if I want to find the kth largest element, I can just pop off k, right? Because that's what I'm trying to find. That's my brute force approach. So maintain a heap to insert the streaming elements. K. I will have to pop off k elements to find the k's largest element. This heap has to be a max heap, right? Okay. So in this example, let me see. All right. Okay. So if I insert this into a max heap, right? So it's going to be in this order: 5, 4, 3, 2, 1. Let's say k equals 1. I will call a heap pop that number of times. So call heap pop. That's retrieving the first element, and that should be my answer. One thing about this is I'm thinking, yeah, this is my brute force approach here, is to just insert them all into a heap, a max heap. And then since we're finding the kth largest, I would pop off that many times. And the last element popped off based on k times, that will be the kth largest.
Okay.
So, okay, so now I'm thinking here, that would be my brute force approach. Okay, or no, actually, I take that back. The naive approach of this would be to insert all these elements. Let me see. So insert elements into a list. Call sort on the list. Traverse from the end of the list k times. Will give you the largest, the k largest element. Okay. So this is inefficient because there's really no way to keep order in this list. You're just inserting them from the stream, right? And it's not given that the stream is sorted or anything like that. So every time you have to call the k largest function, right? To get the k largest element, you would have to call sort on that list. What if you call that many times? You have to add more elements to that list and call sort again. So the inefficiency on that is that you have to sort the list many times over and over. Okay. So if we use a heap to maintain this, it's a more structured way to maintain. For example, a heap will give you the max or min elements, right? In log n time. So as you add elements, it will keep your data structure sorted. So
one thing just to say, so for your brute force, I think we're only calling it like, we don't have to call it that many times. We're only calling like once over, so you don't have to like keep calling sort on as you insert elements. From what I'm understanding from your brute force.
Okay, so if that's the case, I can just call sort on the list. That would be and log in, right? And then to get the kth largest element, it's going to be plus k, right? Because you're iterating from the end. Yeah. Okay. Where's from? Okay. So. Okay. Yeah. And k is going to be given. Okay. I see now. So. Okay. So my next step here is we don't care about Hold on. Does that sound right? Okay. My next step here is to my next step in thinking here is we don't need to keep all the elements necessarily in memory in the data structure. So what I mean by that is like let's say we have 1, 2, 3, 4, 5, right? And then we have 7, 8, 9. Let's say k equals 3, right? Do we really care about what's here? What's here in the beginning? As we're streaming these numbers and inserting into the data structure. So my answer would be no, because we only care about the kth largest element, right? So we can reduce the data structure in this, the data size in the data structure. So if I take advantage of a max heap, that would reduce it. For example, you would have to traverse all the elements, of course, so that would be n times log k, right? K being the kth largest element that we're trying to find. Okay, so yeah. Okay, yeah, so I want to go ahead and do the heap approach here because it'll be much faster than calling sort on the entire list and then traversing from the end.
Okay, that sounds pretty good. Do you want to try like one more optimization? You can think of one more optimization sort of thing.
Okay. Okay, so kth largest. Okay.
Like, what do you think's inefficient so far? Like, what unnecessary work is your heap doing for this algorithm so far?
Yeah, the necessary work is let me see. So I traverse all the elements, right? Okay. Let me see. I'm trying to find. Yeah. Okay. Yeah. I see what you mean here. Yeah. So, like, say in my example here above, right? K equals 3, right? But I already have 7, 8, 9, right? So let's say I have more entries here. It's 1, 2, 3, right? It's still going to have to insert these values into the. I guess it still has to do a comparison, right? It still has to do comparisons, and this is to determine whether we should insert into the heap or not. Yeah. So yeah, that's what I would say would be the inefficiency here, is we're still having to look at elements and insert them into the heap here. As far as something more optimal here, let me see. So yeah, so the list isn't going to be sorted when I get it from the stream. So just throwing some numbers here. Okay, so how can, so no, we already went over sorting. That's not faster than the heap. How much time do I have left, by the way?
Pretend, don't worry, I'm keeping track of time. Don't worry about it. Pretend this is like an
Okay,
actual
okay.
interview.
Okay. Okay, so hmm. Yeah, yes. How can so basically I'm stuck here is like trying to go for a more going for a more optimal way than an actual heap, right? Um
Okay,
so I'm
so
trying to think.
far, you specified the heap as max heap, right?
Yeah, a max heap, right?
Justin,
Okay.
talking to the mic, by the way.
Okay. Okay, so you specified so far as max heap, right? And
Correct.
yeah, so max heap. Think about the size of your max heap in proportion to your stream of elements. Maybe that might help.
Okay, so my heap is only gonna be k large, right? But I still have to run it through all the numbers. Does that answer? Is that in line with what you were saying here?
You're on the right track. Yeah.
Okay, well, okay, so the idea is to keep a heap of size k, right? And then as you look at numbers, right, you're gonna compare what's on the heap, right? Okay, yeah. Let me write this down because it's better to explain, right? So going an example is better than explaining, right? So yeah. So let's say my heap is trying to okay. Oh, okay. So if I'm trying to maintain the kth largest element, right? If I'm trying to if I'm trying to maintain the kth largest element, right? I'm looking at this example 789, right? Okay, so actually I take that back. I'm not gonna use the max heap. Because if I use a max heap, I still have to iterate. I have to pop off k times for my heap. So if I use a min heap, like in this example here, I can just return the first element, right? So let me run through an example of how this would work, right? My min heap is 1, 2, 3, right? And then if a new value like 4 comes in, what's going to happen? The max heap is size 3. I'm at capacity here. So I see that my min heap, my new entry is much larger than what's on the top of the heap here. Okay, so what I can do is I can pop off the first element and then I can insert this new element, right? And I would do that for all the new numbers that come in. So, okay, so maintain a new heap as new numbers come in. As new numbers come in, and the min heap is at length k. Compare the first element in min heap. If the streaming number is greater than top of the heap, pop off heap and insert streaming number. So what about the case when the number is the same as the top, right? Okay, so if the streaming number is less than equal to the top of the heap, let me see. So okay, so 1, 2, 3, 4, 5, right? And you want to get the top k. You want to get the kth largest element, right? So if so just trying to reason through this. Let's say this is negative 2, right? Yeah. It doesn't make sense to insert this, so we can go ahead and skip these values, even if it's 1 as well, right? You already have the kth largest here at the first position, so we can ignore these. Okay, so in the min heap. Okay, so as new numbers come in and the min heap is at length k. Okay, so if heap is not at length k, insert values into heap. Okay, so I'm trying to see if I caught all the cases here. So if the heap is not at length k, right, you insert the value, and that's going to continue until it's at length k. So as new numbers come in and the min heap has at length k, you're going to do your comparison, right? If the streaming number is greater than the top heap, pop off. If the number is less than equal, okay, sure. Okay, so let me run this through another example, right? Just to double check this. Okay, so this is a stream, right? It's going to be 1, 2, 3, 4, 5. K equals 3. Into my heap all the way into 0.3 is going to be 1, 2, 3, right? Okay, so what's going to happen when I'm here, right? I'm at number 4. So going back to this this logic here, I see that the min heap is at length k. So I'm going to compare the first element in the min heap, which is 1. The streaming number is greater than 1. So what's going to happen is I'm going to pop off 1 from the heap. Oh, sorry. I'm going to pop off 1 from the heap, and I'm going to insert 4 here. And I'm going to insert 4 here. So again, going to 5, right? 5 is greater than the top of the heap. So I'll pop off 2, and I'll insert 5. So at any time, if I want to grab the kth largest element, K was given to us, so that would just be the top of the heap, which is 3 in this case, right? Okay, so I'm ready to code. Is there anything else? Anything else that is unclear that I could explain better?
Do you need to keep k? So right now your heap is keeping the the k largest elements of the stream, more or less. Do you need to do that?
Okay, so
because we can assume like our nk, n is our stream is gonna be really huge, sort of thing, and then k might be almost a little bit bigger. Yeah, a little bit like a large number too, essentially. So maybe we can avoid having
that k storage, right?
Yeah.
Let me see. Okay, so we already reduced it from n to k, right? So how can I make this faster or more optimized? I'm thinking here. The heap is not length k. Insert in values into the heap. Let me see. Okay, so with this simple example here, right? Let's say k was 4, right? yeah, I'm just trying to see how to avoid this K structure, right? K, let's say K is 4, right? Let's say K is 4 then. So yeah, and it's not guaranteed that the numbers would come in a sorted fashion, right? So this is what this would be my answer here. Yeah, I need some sort of way to maintain order, right? The sorted order. To grab this. Okay, so I need a way to maintain the sorted order, right? Because okay, so okay. Yeah, and with the heap, I think I have to go away from this idea because there's really no way to reduce that K space, right? That I need for the Kth largest element. So, okay, so okay, okay, so let's say the numbers are okay, so let's say the numbers came in like this, right? How, if I want to find the Kth largest element, right? Then the numbers are not necessarily sequential, like 1, 2, 3, 4, 5, right? They can come in any they come in any manner, right? So yeah, so here I was thinking of using indices to sort to retrieve the Kth largest element, but that doesn't work because the numbers are not sequential. That only works if the numbers were sequential, but not for this example. That would certainly reduce the space, right? So okay, so okay, okay, this example it doesn't help us, right? This is more for like cyclic sort. So let me do. Okay. Okay, so if I call sort on this, it's gonna be n log n, right? If I call sort on this, it's gonna be n log n, right? So that will sort them. And then to find the Kth largest element, that's just gonna be okay, that's gonna be the length of the array minus k, right? So here in this example, let me see. See if I go. Okay, to find the Kth largest element is gonna be length of array minus k, right? In this example, it's gonna be 0. Yeah. So like let's say it's k equals 4, right? Okay, so length of array, it's 5 minus k. It's going to be 0, 1. It's going to be 1 here, right? This will give me the Kth largest, right? However, this is in terms of space, right? Like so going back to the heap and the sorting, right? the heap will be n log k runtime, right? So let me see. And then space is k, right? Sorting, it's n log n. The runtime is n, right? This is assuming you're using like if I use a quick sort versus merge sort, right? We can definitely get rid of this n space, right? If we do it in place. Okay, so it certainly does reduce your space, right? But it's not going to be much faster.
Is there a way to utilize some of the sorting methods to increase the runtime, to improve the runtime?
Okay, so is there any way to use the sorting methods to improve the runtime, right?
I'm gonna shut it off right now. 30 minutes in. I think we have a pretty good idea of what's gonna happen. But I want to actually. The reason why I'm stopping it here as well because, I know what you're trying to do, Jay. But I think that I don't think that's as fair. Yeah. If you're doing what I think you're doing, and you're gonna go after like ask him to implement a pivot, I don't think that's fair.
Okay.
So, you know, I'm gonna. Do you think that in light of that, do you want him to try cutting it out in the last 5 minutes, or do you think you have enough signal?
Actually, try coding out the heap solution.
Okay.
That works too. Yeah.
Yeah. Let's go ahead and do that. I'll give you 5 minutes to do it.
Okay, the heap solution.
Yeah. Go ahead.
Yeah. Yeah. Try that.
Okay. Okay. So let's call this we're given like the stream, right? And then
yeah.
K, right?
Yeah.
Okay, so I have my min heap, right? Min heap heap. Okay, so I don't need to do anything to the values I insert, right? That's only for the max heap. Okay, so for this stream, okay, yeah, for this stream, my next question is like, we don't know the size ahead of time, right?
Yeah, you don't know the size ahead of time.
Oh, shit. Okay, so I have to have like some sort of add method, right? I need some sort of add, and then I need something to calculate the kth largest, right? To return the kth largest element here. Okay. Okay, yeah. Yeah, because this changes because I'm not just iterating over a fixed size of data. So, okay, let me change this to a class. Add number. Okay, so here it has my min heap, right? Okay, so def add, okay, yeah. Add just does a simple add to your heap, right? This is a heap queued, heap push. You pass in self dot min heap, and then you pass in the value, right? Okay, so now calculate def calculate in largest. So self k is already given from the top, right? So let's add this here. Self.k equals k. Calculate. Okay, yeah. This is where I would incorporate all the logic. For example, if length of self dot min heap is less than k, right? since self.k, you just insert it into the heap. Otherwise, I can incorporate this logic here. If length of self min heap was equals self.k, then I have to say, as new numbers come in and the min heap is at length k, compare the first element to the heap. So if a number is greater than self.min heap, get the first element. If the pop off the heap, so q.heap pop self.min heap. Okay, so I popped it off and then insert the streaming number. So q.heap push self.min heap. Insert the num. Okay. And then for the numbers that are the same as the top of the heap, we'll just ignore those. Okay, so let me see. So going back to if heap is not at length k, insert, okay. Let's new numbers come in. Okay. Okay, so the calculate kth largest, that's just simply doing self dot heap, right? The first element, right? We still have to check, for example, if I have to check if the heap is empty, right? Obviously, if self dot min heap, then I can do. Okay, I don't need shit. Okay. For this, I can just return -1, right? Or I can return for the sake of this simplicity. For the sake of simplicity, I'll just return -1, indicating. Yeah. Okay.
But -1 might actually be a legitimate number. That's the problem.
Oh, okay. Yeah.
Just
yeah,
return,
so,
I would say just return nil or something.
Return none, right? Okay, yeah, that makes sense. Okay, so yeah, and this you would just call it as so like let's say you're streaming, right? For number in stream, you just say like you instantiate your class, right? Okay, the largest element. No. So I don't know the stream ahead of time, right? I just know k. So the min heap's just gonna be the empty list and then self k. So I can just instantiate the kth largest element with k, right? Or no. Hold on. Okay, so yeah, the naming is fucked up here. Yeah, I messed up on the naming here. It's just I should calculate. Okay, so the class is called kth largest element. You add, and then this should be called get kth largest, right? Then in your stream, you simply do let's say it's like while stream, right? While stream, you just do kth largest dot add stream dot value, right? Value, right? And then at the end, you just say kth largest dot get cave largest, right? For this one, I don't necessarily need K here because that's already given, right?
Mhm.
Okay. I'm gonna stop it here. Okay. I mean, I have my thoughts on what happened, but I'm just Jay. I think you should go ahead, give the feedback first. Well, actually, no. Let's start with the C. Say what you did.
Yeah.
Talk about what you did right, what you did wrong, what you could have done better, and then Jay will give you feedback. Then I will.
Okay. What I did right was I started with simple examples, right? Trying to get the idea and what was expected of me here. What I went wrong with is like I started talking about some idea I had, and then I went back to the brute force. That should have been the opposite. I should have talked about the brute force first, and then build up my idea from there. Also, I couldn't think of how to move from the heap solution, right? I also didn't. I also messed up the heap, right? Because first I was talking about doing a max heap, and then something clicked on my head that we should use the min heap instead there.
Okay.
And yeah, and what I should improve is basically yeah, I would say more practice on the heaps, right? Because I did spend quite a lot of time going back and forth with the min and the max heap, right? If that was more solid, this would have been much quicker.
All right. Jay, your thoughts?
So yeah. First of all, so sort of is my fault for a little bit pushing for that pivot solution. My bad. See.
Oh, no problem.
But yeah, other than that, I mean, yeah, it would have helped in the earlier beginning when you specify what kind of heap, and then went through the heap. I think it would have saved you a couple minutes there. The backtracking from your heap solution to the sorting one felt kind of off a little bit. Like, why are we going to a more brute force solution after we've already discussed a little bit more optimized one? But I get if it's for your clarity. Other than that, yeah, for your test, I was a little confused why you're trying about a few random numbers. It might have helped to specify what kind of property you're testing. To me, it just felt like you're just trying random numbers, like a little bit of a shotgun thing. Like,
Okay.
let's try random numbers and hope we can find something out of the test that we got. Other than that, yeah, I think you're fine. The coding was a little bit weird. I think, yeah, it is kind of your fault that you did. Your naming was fucked up. And then, yeah, I mean, at some points I was just a little bit confused. It seemed like you were trying to look for a way forward. I understand that, but I was just personally a little bit confused. Like, what are you trying to do at this point? I think it was in the like later parts when you were thinking about when you were trying out examples again after the min heap solution, trying to get for the pivot solution.
Okay. Just going from the heap to the pivot. Okay.
Yeah, that's. I do have a little bit of timestamp, but I think it's gonna be a bit off. But
Yeah, just paste them. It's
can send
fine.
it to you.
Yeah, go ahead and do that. I kind of want to jump in on this. Yeah, you pretty much nailed the first part. It's like, hey, wait a minute, why are you going back to your original solution? It seemed like, hey, you came up with a brute force solution, talked about a naive optimal one, and then went back and forth. So to me, you definitely lack your own direction. It wasn't very clear why you're doing it, and I think that's. And I'm like, I noticed that you tend to do that back and forth when you don't have a clear idea, and I've kind of stressed to you, hey, you need to make sure your idea is bulletproof. You understand why it works, why it doesn't work before you go on. And I think that it kind of keeps coming up again and again. I'm not quite sure why, where you basically come up with the next idea, but you actually don't. You have a very poor understanding of that idea as well. So, and then you kind of saw it in the coding actually. So notice here, you only really wrote like what? Let's say this is like 15 lines.
Mhm.
It took you 7 minutes. It took you 8 minutes to write it. So that's like 30 seconds per line. And to me, it's like that. That's really bad. That's really bad. This coding thing, we always aim it to be like 5-6 minutes, because unless like you have some really long line of code. But this one is not that. In fact, you came up with this idea pretty quickly, and I guarantee you've seen it before. So this code should have been very easy to write. In fact, you even have the pseudocode up here. So are you not looking at the pseudocode when you write? Well, and I'm trying to figure this out actually. let me ask. When you're writing this code, did you look at the pseudocode?
Yeah, I did, but yeah, I think I should have done bullet points to make it more clear because it was like sentences here.
Okay, so as new numbers come in and the min heap is at length k, okay. If the min heap is at length k, yeah. Compare the first element in the min heap. If the streaming number is greater than the top heap, okay, so streaming number is greater than the top of the heap, so okay, so if the number here is greater than the top of the heap, pop up the heap and insert the streaming number. Yeah, right here. So the streaming number is less than the heap, continue. So in other words, you basically, this wasn't, it said and the min heap is at length k. So this is where your pseudocode, so this part of the pseudocode is incomplete. Like, wait, what? Notice here that I was like highlighting the areas in train of thought, right? So this part is fine. It's just this idea was incomplete. So when all you have to really do is ask yourself, hey, wait a minute. When I go into this function, what are the possible scenarios? The number I'm bringing in is less than the top of the heap, equal to the top of the heap, or greater than the top of the heap. Just handle those 3 cases, and then you would have, and that should have solved itself. So you saw that here. This is actually these 3 lines are where you struggle the most, because you didn't come up with all your cases. In other words, it goes back to bulletproofing. Did you cover all your cases? And you didn't do that. And again, you saw it as a consequence of the code you wrote. That's it. Other than that, again, there's this like gap that I'm trying to fix of you not understanding your code before you write it, and I'm having a difficult time trying to find out what the solution is going to be. And I can point out, hey, there's a mistake. Hey, bulletproof your idea. Run the idea through examples, but it's up to you if you want to have the discipline to do it. Like Jay even called out, hey, why are you trying random examples? Why not be disciplined about the properties you're trying to test?
Okay.
So yeah, that's my biggest feedback to you. All right, let me use the bathroom and then we'll switch roles. Feel free to talk amongst yourselves.
So how was it, C? How did you feel during the interview? I know I messed up as an interviewer. My bad for that.
Yeah,
I was kind of nervous too, but yeah, how did you feel as the interviewee?
Yeah, I think like I had the idea, but then you said, oh, there's something more faster, so that's where I got stuck, right? I couldn't go to the pivot approach that you guys talked about here.
Yeah, I think like if you like probably saw something, I don't know. I think if we disregarded the pivot approach, I think you would have solved it like a lot quicker, sort of thing. But yeah, the pivot approach was like it was something similar to quicksort.
Okay, quicksort.
Yeah, something similar to quicksort. It uses is like doing the pivoting in quicksort, but not fully sorting the array, sort of thing.
Okay.
Like you just pick a pivot, all the numbers larger than it will go to the right side, all the numbers smaller to it, then k, the pivot will just go to the left side, something like that.
Okay, yeah, because you mentioned there was something faster, so then I thought of doing something with sorting, right? But then looking at the heap solution, it's n log k, right? And sorting would be n log n. But if you sort it in place, it's just O of one space, right? Yeah. So that was. Go ahead.
No, go first.
Yeah. So that was just me like trying to think of how to sort this, right? Because I also thought of doing the cyclic sort, but that wasn't going to work because the numbers weren't sequential, right? There's no guarantee that they were. So.
Okay. I'm back. Yeah. So the reason why I suspected you might be doing some weird manipulation with sorting was basically because of that. And then I just ran through my checklist like, hey, wait a minute, are you asking him to implement some kind of pivot sort? And I'm like, that's okay for maybe new grad, but keep in mind, like, most people do not know how to do that or would have thought of that even. You have to put it on your head, right? Put it on its head, right? If someone asked you that question, Jay, would you have been able to do it without prep?
Before you, probably. No, probably not, because after, like, I remember during one of our sessions, I was like, shit, about I racked my head about like specific problem sort of thing. And then I have it. So I have the pivot idea in me at least.
Yeah.
But maybe coding it out.
So you're biased towards that. That's the problem.
Yeah, the bias.
It's like, again, when we ask these interview questions in general, it's like we're not trying to get the gotcha. We're trying to basically just say, hey, this guy's thinking is clean and logical. And again, you have to flip it on its head. If I asked you this question without and you had no time to prep for like leak code and whatever, would you still be able to solve it if you were thinking like a reasonable human being? You know, like in our sessions.
Yeah, probably not. Yeah.
Yeah. So you can't. It's like you can't ask that question. That's why I cut it off there. So that's fine. All right, we're gonna switch roles now.
Yeah, you can see me crash and burn now. Haha.
It's okay. And see, hopefully you got some like interesting like notes from him as well.
Oh yeah, for sure.
And Jay, did you start seeing like some of your mistakes in him?
Yeah, I did.
So you're not
Still,
gonna.
yeah, I do like in your earlier streams. I do remember it's like, see, it seems kind of like a mirror. It feels like I'm kind of looking like a mirror sort of thing when I watch the stream a little bit.
Yep. So I figured instead of me like talking at you, it's I'm gonna make you guys feel the pain of looking in the mirror.
Yeah, for sure.
All right. Okay. Next problem. Time. Let me bust out the timer and yeah.
All right. Let me paste this image example.
Okay. So I'm just gonna divide it with the equal sign. I mean, don't get me wrong. Like, I no matter what engineering level you are, I still find that everyone has this like problem of over talking and over rambling, especially when they have very little ideas of their own. I mean, come on, you can just look at YouTube, Reddit, or whatever. People just like write these long-winded form of information that amounts to nothing. It's a common human trait to ramble. So
yeah, I honestly remember like in my earlier years of university, I'm like, you know what? I don't want to read this book. I usually just read the first sentence of each paragraph, sort of thing, just get the basic idea, and if I find it interesting, I'll just read more into the paragraph.
All right. With that out of the way, let's go. Whenever C's ready.
Hey man, I can't seem to insert an image. I was able to insert one earlier in my talk.
Do you need an image for this one? I know probably trying to ask, but I don't think you need it. Do you?
Okay, sure. All right.
All right. Do you think? Okay, I'll answer some questions on the stream while you're looking for it. Do you think English not being your first language makes it harder to speak out loud and keep your thoughts together? Probably. But if you look at what Matthias did, his like if you watch his my old streams with him, I basically harp on him for like I know like Portuguese is your first language and English is your second, but he still actually managed to come out okay. So look, if some guy's first language is not English and he can speak relatively clearly about his thoughts, I'm pretty sure someone whose first language is English can do much better, you know. But the fact that he's not kind of shows that he really worked hard at it. So go figure. All right. So whenever you're ready, C.
Okay. Yep. The problem's there.
Oh, is
Jay?
it?
Okay.
Wait, where'd it go? Oh, did you put it?
Oh, sorry. At the very top.
Okay,
You want me to
fine.
move it down?
No, it's fine. It's fine. It's fine. I'm gonna just cut it off with the equal sign. That's fine. Let's go.
Okay. Let me just.
Oh,
paste
sorry.
it.
Oh, yeah. Sorry.
Oh, okay. I thought you were gonna. Okay, yeah, go.
Okay, so the problem is, given a binary tree, connect each node with this level order successor. The last node of each level should point to the first node of the next level. Okay, so let's see the input really quickly. That's the binary tree, assuming root is 1. Yeah, those are the leaves. And then we output 1, 2, 3, 4, 5, 6, 7. So let's see how, yeah?
hold up. See, this looks a little easy. Are you sure this is the question you want to ask? I mean,
I
we
don't
can
mind
go with
doing
it,
a
but
different question.
I just want to make sure that this is the right one, or unless you had a
Yeah. I was gonna ask the website visit patterns, but that one I didn't quite get that well. So yeah, I switched my mind on that one.
Okay. Yeah, I can explain that problem after, by the way.
Okay, awesome. Thanks.
Okay, so I'll just continue then, I guess.
Okay, so actually, let's add a twist to this, right?
Okay, sure.
What if Okay, yeah. Let's add a twist to this. So instead of doing 1 to 2 to 3 to 4 to 5 to 6 to 7, right? Mm-hmm. Let's do 1 to 3 to 2, 2 to 7, 7 to 6. So my output would be like this, right? 1, 2, 3, 2. 7, 6, 5, 4, right? So one thing I forgot to paste here is this is a tree node. This is a tree data structure. You have your left, which is a tree, right?
Yeah.
Then you have your right, and then you have your val, and then you have the next pointer. So,
Okay, yeah, no, I understand. Yeah, you go ahead.
Okay. So if I call next, if I get the root node, and then I output its value, and then set. It's sort of like oh shit. Okay, so sorry for this. I start at the root node, right? I print the value, then I call let's say I set the root to current, right? I'll print the current value, then I'll do current equals current dot next. I will print that value, and then I will move the current pointer to the next value, etc., all the way till I get to the end.
Okay. So basically, like a linked list sort of thing, like
correct. Yeah.
Okay. Okay, so is that all? I guess.
Yep.
Okay. Okay, so let's go with the connect the input to. Let's connect our input to the output. Like essentially, not essentially. Basically, let's try and understand what we're trying to work with here. So it says level order successor. But in this case, it seems that each level is reversed. So when I see level order, I'm thinking breadth first search, and it seems like we have to traverse this tree in a level by level manner anyways, because we have 1 over here, then we have 3 and 2, and then 7, 6, 5, 4. So it's essentially just this breadth first search with one while we revert. It's breadth first search, but we reverse each level. We reverse each level and connect the dot next pointer to the one beside it.
Mm-hmm.
So 3 dot next would be equal to 2. Then 2 dot next will be equal to 7, 6, 5, 4. So let's go for the naive approach first. Naive approach is what I'm thinking is just we do the breadth first search, so it'd be 1, 2, 3, 4, 5, 6, 7. But when we process a node, we add the node to a queue, and once we pop the node from the queue, we just do dot next on the pop node, and we connect it to the next node that we pop into. So just to write it all out a little bit, so breadth first search on the tree. Pop, add root node to queue. Pop node from queue. After we pop the node from queue, take .net, record the pop node, and then after we record the pop node, we do dot. I'm trying to record the first pop node, and then once we pop it again, we're going to call dot next on it. I'm having a little bit of trouble trying to explain that in English. So once we pop the node from the queue, we record the pop node, and then for now, as a placeholder, we'll just leave a space in here and put in pop node dot next equal to the current node. Yeah.
Would an example help here? Explain it better.
Sure. Yeah. Okay. Let me try that. Yeah. Okay. So
if that works for you, or if English
okay.
is better. Yeah.
Yeah, so let me just try that. So we'll have in queue over here, and then we have 2 and 3. So yeah, we have 1. We pop in, pop node will just be 1 after, and as a queue we add in 2 and 3 because it's best for search. And then once we pop out 2, we'll do dot next equal to 2, and then now our pop node will now be equal to 2, and then after that, of course, once we pop it to 3, we do dot next 3, and then our pop node will be equal to 3. So the caveat in here, how we modify this to the order that we approached earlier, the order specified earlier, is that we would just, at each level of our tree, we would just call a q dot reverse on it. So let me just copy that. Yeah, so add root node to q, pop node from q. Yeah, q dot reverse. So to go through the example again, but with the proper input, it would be one dot next. We put in 3 and 2, so it would be 3 here, and then we record 3, 2, 2, and then 7, 6, 5, 4 would follow the same approach as the binary tree 1, 2, 3 that we have here. So yeah, so that's the approach I'm thinking of as soon as we add the root. Reverse now is just trying to find out how we can have the pointers together, have the pointers interact with each other such that I can do this pop node and then do the dot next after. So when we're doing the breadth first search, we'll just iterate over all the entire level. Once we pop, let's just think about the second level, 2, 3, to make it easier for ourselves. For an example, so we're on 2, 3 right now. Let's just say that 1 is already recorded, because since it's the root, we can always just set the variable to that. So let's see how we can handle 3 and 2 at this point. So if we're pop node is 3, and then we pop another node. Okay, I feel like I'm repeating my example a little bit. So yeah, I think I'm repeating my example a little bit in the beginning.
Will your example handle the case of going from 1 to 3, right?
Yeah,
right here, where my
yeah. I'm trying to figure out 1 to 3. Yeah.
Okay.
So, of course, if we already have it recorded first, then it would just be pop. It would just do 1 dot next equal 3, and then pop node equal. Yeah, okay, I think that works now. So 1 dot next equal 3, and then after that, the code. Okay, so the code specifically would be pop node is specifically equal to 1 in the beginning of our area. So then we have our queue over here. We do the pop next equal q dot pop again, and then yes, well, we do another next node. Essentially would be q dot pop over here. We call it the next node. After our next node is done, we do pop dot next node, and then I think that would handle everything else. This is the order in our operation. So we have our initial root over here on the pop node. We add children to it. Then to our next node, we'll just pop from the queue, so that'll pop out 3. And then after that, we call the pop node dot next, which is pointing to 1 currently, the root, and then we will point it to 3. After that, pop node is now equal to the next node, so which is 1 now. How does that sound for you? Should I clarify a little bit more with examples, or does it sound okay to you?
Yeah, I think what you're doing makes sense. But if it helps you, do you have like the rough idea or the pseudocode? Sorry.
Yeah. Okay. Yeah. I'll write out the pseudocode then. Yeah. Okay. So.
Or sorry. Before we move on, I noticed you use reverse to get the reverse order, right? Is there any way we can improve that?
Okay. So let's go. So reverse order, what we're trying to do is reversing the current level. So my first thought is, instead of reversing the entire queue, we can just add in the right child first and then the left child. So
cool.
To get the reverse order instead. So just to sanity check to make sure it actually works and I'm not just talking on my ass. So our queue, let's actually just copy the whole tree. So, okay, so I'll have it listed down here. So first we would have 1, and then we actually, yeah, okay, so queue, it would be 1. We pop out 1, add in 3, then 2. After we pop out 3, we would add in 7 and 6, pop out 2, that would be 5 and 4. All right, yeah, that sounds good.
Cool.
I think we can just
awesome.
the right child first.
Cool.
Okay, so yeah, I think I'm ready to code. Oh wait, let me put in the pseudocode first. Yeah.
Or it's up to you, whatever helps you.
Okay, yeah, I think I can code it up then. Yeah. So, the tree structure. I mean, the tree node looks like the one given to me. So let's go through the algorithm. So what's the name of this? Connect all level order siblings. Just paste that over here. Sorry. Yeah. Let's just fix
Yeah, don't worry about formatting. It's fine.
Okay. Yeah. Sorry. Okay. So after that, we're given the root node. Simply, that's just tree node. Queue will just be a queue. We specified dead queue because that's the only thing Python has in order of a queue without me implementing it myself. But we'll be using the popping from the left side anyways to simulate a queue. So after that, this is just typical breadth first search. Pop node equal queue 0 just to specify that we have our root. So pop node equal q dot pop left. I now notice that's a little bit awkward over here, having initialized twice. So I think we can get rid of this. Actually, no, I think that would be useful. So yeah, okay, so pop node, and then after that.
One quick question: why are you popping 2 times?
No, I'm not popping. This is just getting the first element. I'm only popping it once so far.
Oh, what are you using for pop node though? That's what I'm not understanding.
Like this?
Oh no, sorry, the variable you erased.
Oh yeah. I just called it pop node.
Okay.
Yeah. It's just like the first node that we pop out from our queue. So after that, I don't think the number of elements in our order matters, so I'm just gonna use a random variable for that. So this is where I iterate over the entire level, over our tree. So queue currently, yeah, our queue is gonna have all elements in a current level. So after that, pop node dot next equal pop. So yeah, okay. We have this over here. Oops, sorry. Little bit backtracking here. Q dot pop left. So we are popping here. No, we're not popping here. Let me go back to the pseudocode one more second. Well, the order that I had to pop node. We already had initialized. So pop node. Add in a case here. If length of Q is equal to 1, so this should specify that our first, this is just to specify the root, just an edge case for a thing to ignore it. After that, it would be, okay. Q, collections.pq. You have a pop node, we pop it. For now, let's just implement the skeleton of the breadth first search, and then figure out the details pertaining to our problem first. So it would be q.append if pop node dot right. We append the node over here, and then if pop node dot left, q.append pop node dot left over here. After that, this is where we connect the siblings, and then after that we would just return
You can just return the root. It's fine.
okay, no, yeah, over here we're specifying 1 3 2. You want me to return them in a list, or is it okay to just, I'll just return them in a list. Like 1 3.
Do you even need a list for this?
Do I? Okay, no, I don't. I can, because you're gonna call that level that dot next. You're just gonna iterate it like over a linked list, so I only need to return the root, so that's not too bad. Yeah. Where is it called? Root. Well, actually, I don't even need to have another variable. I can just return the root. Yeah. Okay, so now this is the basic skeleton of the breadth first search. It appends everything in the right order. We just need to make sure that we can get the next, the consecutive, the sibling element after we get the initial element. So pop right, pop left, that's it. We have to connect the siblings. I think we can connect the siblings over here. It doesn't really matter whether we do it before or after. Well, we should do it during our for loop anyways. So let's have it here. So this is a loop. We're looping through all our elements. Oh yeah, okay. So we can have pop node dot next equal qi. Yeah. Qi over here. That would implement the rest of it. So then, actually, yeah. My bad. If we have it here, oops. And then pop no cut left. So now we're popping out all the elements iteratively from our queue. And now after we append them, we can do the dot next over here. We'll have a flag. So I'm sort of flailing around a little bit with the code. Okay, so here it is. We popped it left. After we pop it from the left, that is our node that we want to do. And now we should have a flag to indicate whether it's the first sibling or the last sibling. So if a equals 0, then if I equals 0, then we don't do anything. If pop node have a current node.
Wait 1 second. You
Yeah.
said if we're at I equals 0 at the first element, right?
Yeah.
What happens if it?
Keep going.
What happens if you're at this level, right? Don't you have to connect the previous to the next, to the first element? Sorry, on the next list.
Yeah. Yeah. So we're trying to get 3 connected to 2 now. Yeah. I was thinking about a special case, but I think that's kind of gone away now that you mentioned that test case. The special case was just the root connecting to the next level. Yeah, I'm having a little bit. I'm trying to connect the root to the next order. So, if we specify this as none root, yeah, and then third node, yeah, dot next, yeah. I'm debating whether I think I should include pop node dot next here. Equal cur node. Well, now it's previous node with the semantics. So pop node dot next equal previous node here, pop left, and then now pop node dot next. Pop node equals previous node here, and I think it now works. So let's try to. So if this follows my idea correctly, anyways. So we had node over here. We're at 1. Well, we're traversing 1 first. Our queue is only 1. So you pop out 1 here after the do the dot next. None for now. Dot next. After that, previous node is equal to null. That is not exactly what we want. Yeah. I mean, I could just put previous node should not be here. Q.0 over here. And then now this works a little bit better. Pop node is now 1. Dot next is now 1. Pop node is now also 1, but now like pop node is now equal to 1, but now this handles the case with now when after we add it, the queue now holds 3 and 2, and we can do the 3 and 2 dot next to 2. 1 dot next to 1 dot next is equal to 3, and then 3 dot next is equal to 2 here. And then since we're returning root, should be fine. Should I run a test case to should I run another
yes.
test case to understand?
Yeah, yes, please. Yeah.
Okay.
You can run it on the first 2 levels. Make it easier.
Yeah. Okay, so yeah. Alright, so let's just run it over here. So we iterate through our queue. Initially, we just have 1 over here with our initial root. Our previous node is equal to 1 over here. After that, we iterate through our queue over here. As you can see, we pop out the first node. So pop node will be equal to 1. After that, our pop.next will be equal to 1. Let me specify let me write down a different line.
Is that what we want though? Point it back to itself though?
I think we're going to go point it. We're gonna rewrite it again in the next iteration.
Okay.
So it will just turn out to be 3 next. Yeah. Well, yeah. Okay, so yeah. After that dot next, we pop in 3 and 2. Oops, 3 and 2. Get rid of the 3. Yeah. Pop node. Yeah, prop node is equal to previous node, which is just 1 still. Yeah. And then after we go through again, pop node dot next is now equal to previous. No, pop node is we pop out 3 from there, so pop node is now 3, and then pop node dot next is equal to pop node dot next is equal to previous node, which is 1. Okay, that's not what we want. Yeah, you're right. My bad. Yeah. Well, 1 dot next is equal to 3. Okay, let me try from 3 again. So we pop out 3 from our queue. Pop node is now 3. And then our previous pop node dot next, our pop node dot next is equal to the previous node. So that's equal to 1. So it would be 3, 1. So I messed up on my example. Yeah. If we have a next node, that could also be equivalent. But I think the previous node 1 will work just as well. So, we're trying to get 1, 3 currently. This should handle the order and how we connect things. Now is just how are we gonna connect it in the first place. So we're trying to. So currently we have 1. We need to pop it. We need to pop it and connect it to 3. So if we pop out the first one, we should keep a cache of it. We should like keep a record of the previous node and have the previous node dot next. Oops. The previous node dot next is equal to the pop node. And then the previous node is now equal to the popped node. So then that at least gets the order into 1, 3 instead of 3, 1. That was a little bit of confusion there with my thing.
You were using a current variable, right? I guess you renamed it to pop node?
Yeah, I renamed it to previous because I felt a little bit more appropriate to name it previous. Because the current node is just the pop node. So having pop node and current node variable names, I think would mess me up a little bit. Yeah. We have pop node. Yeah. We pop out 1 from our queue. So let's try this example from the beginning again. So our previous node is 1. Also, yeah. 1, 3. I'm thinking a little bit of an if statement to check if the previous node is none. If we essentially list to none first.
Okay.
And then if previous node is none, then just set previous node to the pop node. So
if that is okay, go ahead. Sorry.
Like this. If previous node. So essentially if it's none, then we can do previous node. Oops. Else this. Previous node equal pop node. Yeah, something like this. Let me just get rid of that line over here. just so we can specify it as a little bit cleaner. Instead of specifying it as the first node to avoid confusion. So if previous node, so now I'm gonna go through the example one more time. So we have one here. Previous node is 1. Our previous node is 0, none.
All right, I'm gonna cut it off.
Yeah,
32 minutes in.
my bad. Yeah.
All right. So, see, give your thoughts.
Yeah, so in the beginning, I think you were talking a lot, so I just said to do a quick example. Also, when you were doing the examples, it was hard to follow. Let me see if I can see it up here. Yeah, when you hear my cursor here, going over these examples at the very top, that was hard to follow there. Also, when I mentioned about the reverse and how we could optimize it, you got the right idea, but I didn't see you write it down on the pseudocode. You did remember it later, which was good.
Oh, okay, yeah. I get it.
Also, I thought your design pseudocode could have been fleshed out some more. Because I noticed you did do a lot of code changes, and they were just like coming out of your head.
Coming out of his ass.
Yeah.
Not his head, his ass, really.
Yeah, because from this, like, you're working from memory, so it's kind of hard to remember everything. And also, like, with the result example, we were trying to like output the result, but we didn't need that there. And also, when you were talking about connect similes, I noticed you were jumping around there since the design wasn't solid. There was a lot of code with no examples. A lot of jumping around. The previous node idea came later into the code. I think if you would have drawn out like 1, 2, 3, right? It's sort of similar to a linked list. I think that logic would have been more clear. And some of the later examples weren't clear. And yeah, you were changing a bunch of code. And then the weird logic of the node pointing to itself, that was a bit confusing.
Yeah, when I was talking, I was like, why am I like this? Sort of thing. I realized I did mess up a lot, yeah.
All right, and see, you recognize that you make these mistakes too, right?
Yeah.
How painful was it to sit through 20 minutes of him rambling?
Yeah, man. I spent like a lot of time with these problems, and prior to the coaching, I did do a lot of these from memory, so I would have to go back and do sections because I didn't remember. It was just like the wrong approach, right? So yeah, it's kind of hard when you're introduced to new problems, right? To like get a good foot on your ground and solve these. That's what I found.
Yeah, but the point I want to do today, and this was a really good example, was literally you make this exact mistake, and I want you to feel the pain of like watching someone struggle for 20 minutes, just go back and forth, because that's exactly what the interviewer is feeling. And now that you have a sense of it, like now I don't have to repeat it, and hopefully it sticks a little bit better in your mind. But as far as Jay goes, yeah, he basically got it. You basically spent 20 minutes patching and praying. All you really have here is a glorified breadth first search, except instead of going left right, you're going right left, and then on each operation you're just gluing it to the previous node that you saw.
Yeah. I got the idea. It's just that dot next part messed me up. I don't know.
No, it's not even that. Again, all it is, if you broke it down to just that those three things, it would have been super easy for you. And so if again, that kind of goes back to like writing it down, but then also having like an automatic framework. I hope you know how to write a breadth first search from memory. Like this should be taking 10 seconds.
Yeah. I got the skeleton down.
Okay, then all that changes is like from reverse, right? Usually you go left right. Instead, you're just going right left. That's just a copy paste, right?
Yeah.
And then all that's left is that at each operation, you're just gluing the previous node to the current node you're looking at, and then replacing the previous node with that node. Rinse and repeat.
Yeah.
So that's basically all that's happening. And in fact, you don't even need. You do need a queue for this. But yeah, you get my point here. Is that all you had to do was just really just flesh out that gluing logic with an example or something. And instead, you just jump straight to the code, and then you did the patch and pray as well. So again, like both of you are making the exact same mistake, and I've harped on it many times. Like, hey, you gotta just test your shit before you go into it. Make sure you have a solid idea. And the thing I'm starting to get is that you guys think you have an idea. It's like, oh, let's go. If you have a vague idea, no. Remember, you gotta cover your ass. If before I made you write code, I said you can never edit your code after you've written it. I want you to treat like that code. The moment you write a line of code, it's dried ink on paper. Or if I said, okay, every line you delete or change, you owe me $1,000.
Yeah.
Do you treat it like that?
Yeah.
Because that's effectively like that's actually what happens in like the real world, right? Because like if the company's paying you, let's say $200,000 a year, and you introduce some like you go back and forth on the code. Effectively, you basically cost the company $1,000 each time you go back on your idea because you didn't think it through. It's exactly that actually. So if you really want me to put a number to it, that's basically what you're playing with here. So I really want you to when you do these practice, both of you, when you're practicing at home. Before you ever write code, I really, really want you to think, hey, yeah, if you edit anything in the code, you're gonna, you basically cost this much money or XYZ. That's how heavily I want you to take this idea.
Mm-hmm.
And I think it'll really help you, like, okay, let me make sure that I got everything, that I tested all my simple examples. Let me make sure I go through all of it. You know, as that checklist I kept talking about, right? It's like, hey, make sure you try your simple examples before you go through. And I think this is a good chance, like, if you guys feel like you guys are good interview partners, I think you guys should, like, also on the off time, like, interview each other just as practice, and then call out each other's mistakes. I think that might be super helpful, even though I know that levels are different, but both of you are going to recognize the same mistake in each other.
Mm-hmm. Yeah, that works for me. Yeah.
So I'll let you schedule that on your off time, but I really recommend you guys, like, try to, like, keep a checklist of all the mistakes you're making, and then call, and really, really be harsh on each other. Because, I mean, I can point out the mistakes till the cows come home, right? But it's really going to be up to you to be disciplined enough to catch them. And I figure that if both of you are making the exact same mistakes, both of you can call it out in each other, especially now that you recognize them. All right. So with that, we stopped a little bit early, but I pasted my notes in there. We have 20 minutes left. I'm going to give this time to you guys. Ask me anything you want, or you want, we can call it early.
I don't know what to say, I guess. I don't know. How you been?
I've been alright. Yeah, it's just like, yeah. And you've seen the streams. Things have just been chumming along as usual. Yeah, but again, the goal here is just to really make sure that we don't repeat the same mistakes from the past. That's where we have problems, and we're definitely making the same mistakes from the past, and I'm trying different ways of trying to remedy it.
Yeah. It was really nice interviewing you, see. I like looking at a mirror after getting like focusing on the input, like actually having to endure it, sort of thing, in person. Not in person, but like you get what I mean. Through Zoom, it was a lot different. Yeah.
Now you know what it looks like on the other side.
Yeah. Oh boy. Yeah. I need to update my mental checklist one more time for this thing after this session. Jeez.
Yeah, and it's also important to think back on like, hey, why am I making these mistakes? Why am I in a position of why does this feel awkward? You know, it's not the last thing you did; it's the setup to it that almost always determines how you execute, right? So it's like all the events leading up before you write that first line of code.
Mm-hmm.
So that's where you want to look. The moment you start getting that gut wrenching feeling, like shit, something's wrong.
Yeah.
That means that there's something in that process that had led you to that moment.
Mm-hmm.
So,
I had a quick question. Like, with the problem I was doing, like I had the heap idea, but then like if the interview asks you what's the most optimal here, like, because that's what I feel like sometimes I get stuck on, right? Like for example, I thought of the heap solution, right? But then what if they tell you there's a faster way? What can you do? Because I feel like I get stuck when those type of follow-ups or questions happen.
Yeah, so basically this is where you would have to, like I said, the efficiency, right? So effectively your solution is n log k because you're going through n number of elements, and log k because that's the size of your heap. And so the only runtime left would be, okay, we can't, it would be like an abstract discussion, right? The first one would be, okay, let's not do the log k on every single element. Let's do it on every x elements, right? And in theory, what we could do is if that x number of elements is of order n, then you reduce your runtime to like n. Yeah, you reduce your runtime to n actually, because you get a fraction of the log k divided by n. So that would be the first leading point. The other one would be okay, because it's unavoidable. If I look at the problem, I have to look at every single element in the stream. That makes it at a minimum order n. And then order k, I have to look at every single. I have to look at like the k elements because I need to know which element is going to be the kth largest, unless I have some way of carrying that past information over, which to my knowledge doesn't exist, is not obvious, it's too hard. Like, can you encode like the past, like every element into like one, let's say number or byte or whatever, and then be able to just reuse that? Probably not. I don't see it. So the only other option is to batch the operations, like I just said. And so thinking about that, then I'm saying, okay, well, if the way the heap works is just I insert and then it'll automatically do it for me. So we have to override that. And so we cannot use a heap because otherwise it'll do the automatic sorting. So we need to implement some kind of sorting algorithm ourselves. Okay, what are the sorting algorithms that we can use that we can run at every k number of elements? There's there is the typical binary what's it called what my sorting algorithms are like heap sort and merge sorts. Those are your options. At least that's off the top of my head. And then the way the heap, what is it? The merge sort that works is the one that uses the pivot. I don't remember.
No, quick sort.
Quick sort.
Quick sort. Okay, quick sort. Yeah, it'd be quick, heap, or merge. Those are your only three options, right? And so I'm going to take those ideas. I just need to modify those three, and I'm just going to go down the list, right? So heap sort, merge sort is the one that divides the array in half, and then two sorted arrays in half, and then merges them together. That doesn't seem like that's going to immediately help me because I need to be able to stack k elements in there. So in theory, I could divide it by like, size k, and then do the merge. But then that's not clear to me, right? I mean, that might work. But this is like the order of logic that I would use. So I'd probably get stuck at, I have to use some element from merge, quick, or heap sort. And then I just like talk that idea out. And then I'd probably just pick, okay, based on that, I think the pivot's the only one that really works here, but I have no idea how to code it up. I would legitimately get stuck on this problem after that point. And this is like me being like, I haven't studied sorting algorithms in a long ass time, but I think it's like being you saw like how basically there's forced chains of logic. There's some areas that are like not obvious, too hard, or like if I wanted to do this, what would it take, right? And I described I needed to have like encode all the past k elements into a byte, and that's not obvious to me, so I'm going to not go down that road. It's like, it's yes, no, or too hard, right? And a lot of things end up in the too hard pile when I was doing this, so. But yeah, you just, as long as you just follow that chain of logic, and you can express that chain of logic, I think any interviewer is going to be like happy with that.
Okay.
Yeah, we're not trying to do the whole gotcha thing. We're just trying to say, hey, if this person is rational, logical, can they solve this problem? Yeah. No. I wouldn't worry too much about that one, but that's just kind of like the chain of logic that you should at least try to copy. You shouldn't worry about the answer, but you should try to copy the logic and framework that I'm using.
Where you're going with it, yeah.
Exactly. All right.
Cool. Yeah, man. I guess that problem, man. You said you were going to talk about the analyze web page visits.
Yeah. Here, let me bring that up. Jay, this one's gonna be good for you too. Let me go ahead and open up the email. So the way that one works, I understand like what one of their solutions actually. It's actually pretty good. And I think it's actually the most straightforward one. So this one is the analyze user website pattern, right? So so I would definitely try to get. Yeah. I would definitely try this again myself. So like, okay, I have a bunch of usernames, I have timestamps, I have websites, right? And these represent, hey, each user is going to use a timestamp, and a web, and this represents like, oh, this user visited this website at this timestamp, right? And so the way one of the solutions would be is like, okay, well, let me take all the sequences I'm interested in, right? So, which is like home. They say 3 sequence: home, about, career, right? Was visit X two times, right? So all I need to do is assemble the sequence of the user, let's say Joe, home, about, career, and then, or Joe might have something else in there, right? And all I do is encode this home, about, career as a single string in a map. And so all I do is then I would scan the website that I have for Joe, and then home about career, cart, etc., etc. So it'd be a sliding window, and then if that tracks, then I throw it into the I do a frequency map for that sequence. Does that make sense?
Okay. Yep.
All it is just it's just a sliding window of websites. Yeah, that's at least the way I think would work. Because the runtime of that is you're gonna get order n for visiting number of websites in order to get the sequence for Joe, James, Mary, or whatever. And then after that, you're doing another order n operation in order to do a sliding window. Yeah, so that gets you order 2n actually, and then the space would be order n and plus the order of the number of sequences you're interested in. I think that's the solution here. So does that make sense the way I described it?
Yeah, that makes sense. The only part there is if you look at I believe it's James, right? It looks like they do some sort of combination there.
Yep.
Because my question is there, how would the sliding window handle this, right? Let me see if I can pull up the example. Yeah, because if you take, for example, A, B, C, D, right?
Yep.
You're also going to have you're going to have A, B, C, right? And then you're going to have A, B, D as well. It looks like they skip some websites. It doesn't have to be sequential.
It's a sequence, not a it doesn't have to be conjoined. There can be a skip in between.
Yeah.
Oh, that's interesting. Okay, I was assuming there's a sequence. All right. Then you could just do you could do like a shit.
Yeah, I think they do the 3 indexes there, 3 indices.
Yeah.
And then that could.
Sorry, go ahead.
That becomes like a n choose C problem, right?
Yeah. It basically becomes like a 3-pointer, a nested loops. Pick. Yeah. Actually, like the what's it called? The nested 3. You know what I'm trying to talk about.
Yeah.
That would basically be what this resolves into, but then that gets you into n polynomial time. Oh, is it?
Yeah, exactly.
Something like that. So there's probably a better way to do it. But that's basically at least the solution I would have come up with, I think. And I think if you submitted that for like your first solution in Amazon interview, I think it would have been good. Yeah, the subsequence one is going to be more interesting because with subsequence you have basically an infinite number of permutations. So there is that's the pointer solution that I talked about before might actually work. Yeah, actually, yeah. Because then if you construct a graph or partial graphs of the sequences, you might actually get there. Because then you could use that try solution that you talked about, and all you need to do is just see the number of pointers that advance to those nodes. But the thing is that you might have multiple nodes for home, a cart, and maps, and you might have to have some duplicate because you can't like have home, carts, and maps be on some own graph. Then you need to have like maps starting the new graph or whatever it is. So there just can't be any cycles. It has to be a tree actually. At least that's the way I think about it. Yeah.
Yeah, man, this problem's not a medium. It's freaking hard.
I think it actually has to be it has to be a bunch of trees. Yeah, that's the way it works.
Yeah.
And then you just see how many pointers reach the end. And then that would actually get you to they get you to order in time actually. Yeah. But yeah, you kind of see like how I kind of went through that checklist. But yeah.
Yeah, for sure.
All right. Any other thoughts? No.
Right. So for Thursday session, just want me to record like some problems, and is there any specific topics I should do for?
I want you to stick with the data structures and algorithms one. I think you're pretty much through the EPI, right?
I need to do like the searching and sorting those chapters.
Yeah, you can do some of that. I think
I need like 3 or 4. Yeah.
Yeah, you can do that. That's fine. But judged on this, I still think that recursion and trees are still some of your sore points.
Okay.
I think. But it's hard to say. At this point, like, you have a decent understanding of a lot of the topics. What's really suffering is just those habits in your approach. So it really doesn't matter what topic you're doing right now. It's really just, like, trying to iron out your approach as an engineer. That's really going to count.
Okay.
It doesn't matter what topic.
Sure.
But yeah, if you have topics you need to finish, then go ahead and do that.
Okay, sounds good.
Right. Yeah, I'll go ahead and exchange information in the Zoom chat as well. Send each other the emails. You're both on Discord anyway, so yeah.
Okay, that's good. Yeah. Yeah. How do you want to keep in contact? Do you want to do emails or do you want to do Discord?
I'll reach out on Discord. It's fine, or email's fine too. If you
All right, I'll
you can
just send
exchange it. Yeah.
my Discord here then.
Yeah.
Okay. So yep.
All right, cool. Anything else from you guys? Like, no.
It was fun being back on stream again.
I'm glad you enjoyed it. Yes.
Yes.
And yeah, just keep it up, man. Like, I don't know if Google's gonna get back to you or not, but you know, always safe to hedge your bets just in case they.
Yeah,
things fall through.
definitely been applying and practicing. I realized I need a lot more practice soon. Yeah.
Yeah, Dropbox is not a bad place to work as well. Just hit up whoever, you know.
Oh yeah, I've been trying. Yeah. I'm just following through this GitHub repository that has a bunch of links. I'm gonna apply to. I'm almost done that. Then I'm just gonna start applying to random companies that I know the name of.
Okay.
Well, not random, but yeah.
All right. Cool. Well, I'll let you guys go then.
All right.
Cool.
Cheers,
Awesome.
guys.
All right.
Have
Later.
fun.
Cool. See you guys. Bye.
Yeah. Okay. Any final questions from the crowd? It's like he's not using Code well. Yeah. I hate graphs with a passion, but you're gonna know he's gonna come with Google Onsite. Yep. So like I said, you gotta make sure that no matter what question comes your way, you gotta do it. I'm like an exasperated parent. Yeah. I mean, I've told these guys like the same thing before in the past, and I know they know it. It's just they keep repeating the mistake. So it's just about being more cognizant of, you know, that you're making the mistake before you even get into it. It's like recognizing, did I cover my ass enough? And this is like where continually making that mistake and recognizing I didn't cover my ass enough is gonna come in. That's like the instinct part, right? Because you can't walk in with a checklist. And I will tell you that a lot of people, like personally have really, really bad memory. So I can't memorize my checklist. At most, I have an intuition that maybe like 3 to 5 points I walk in with about like what I'm most prone to, and I watch out for that. The rest is just like how well you practice. So, all right, that's it for me. Practice is pain. Yeah, but you know what? What's it? Difficult practice makes for easy battles. So, all right, that's it for me. Thank you all for joining me. We'll have a stream on Thursday as well. We'll be talking more about his data structure and algorithms practice, and hopefully that flies over well. So thank you all for joining me. If y'all also want to be coached, you can book me for coaching at echantech.com. Links in the description. Join me on Discord, all my socials. I'm pretty active on there. And yeah, thank you all for joining me. I'll see you